Hello, everyone, and welcome to the October 2024 Integration Down Under. Got a couple of slides to go through before we get started. The organizers, Martin, Dan, Mick, Wagner, and myself. And tonight's talk is Toon, and he will be talking about Azure messaging space. So without any further ado, I will hand over to him. Let me remove mine and add the stage. Welcome.
Thank you, Bill. Thanks for the introduction too. Okay, I think we can get started. So this session is called Help. I'm totally lost in the Azure messaging space. So
Yeah,
before
you
we
want to
dive into
just get rid of that sharing little thing down there.
okay.
Hide that little window.
Yeah,
Yep,
perfect.
there you go.
There we go. Alrighty. So maybe before we dive into a little word about myself. So I'm Toon Vanhoutte, CTO at Vanhoutte. Vanhoutte is a Belgian company that focuses on the Microsoft technology stack. I'm awarded 6 times, I guess, for an Azure MVP. I'm a dad of 2 fantastic kids, and of course, a big cycling fan. If you live in Belgium, you don't have any other option to like cycling, of course. That's why this session? Well, I had a look at my blogs. I'm actually blogging on yourazurecoach.com, and I saw that there was one particular blog that was very popular, and that was actually Service Bus versus Event Grid, where I describe the main differences between these two messaging services. So that was a kind of an eye-opener for me. Apparently, many people are struggling to find the right messaging service for their environment. So that was a trigger for me to say, okay, let's make a dedicated session out of this. So in the first place, why do we need messaging? An important question. And in the end, it's all about to get rid of friction and dependencies between systems. Because if 2 systems communicate directly with each other, and one is down or the other one is slow or whatever, it causes friction, it causes applications to get stuck and so on. So we want to avoid dependencies between systems, between applications, or between organizations, if we take it even further. So that's why messaging is a good idea. You have the sender of the message, and you send the message actually like a WhatsApp message or a text message. You send it asynchronously to a receiver, but in between there is a broker. And that broker, of course, plays a very important role because in the end, you introduce a new dependency. That dependency should be hopefully always up and running and always acting performance. Otherwise, you just create a new problem. So that's why it's important to have a stable and reliable broker. So that's why I advise it not to run it yourself or to manage it yourself, but to rely on a cloud broker. And in our case, if you look at the Azure space, we have 3 main brokers. We have Azure Service Bus, we have Azure Event Hubs, and we have Azure Event Grids. And to start off with, I want to show a small demo of these 3 services, where we have on the left side a console application that will send messages, and on the right side, a console application that will receive messages. And all the communication between the left and the right side is going through one of these messaging services. So let's have a look over here. So here on the left, maybe I need to zoom in a little bit, like this, and also zoom in over here. I can choose the option to send Service Bus to Service Bus, and I just send a few messages to Service Bus. You see the messages are being sent on the left side and immediately being received on the right side. So you see it goes quite quickly. If you do the same, we send now messages to Event Hubs. Voila, you will see it goes as fast as the previous one. 100 messages are being sent, and on the same time, these messages are almost received instantly because our receiver is listening in real time. Then the next one is Event Grids. Let's also give that one a try. Send 100 messages on the left side, and you will see on the right side, we have also 100 messages. All right. So you've seen the demo, and you might, of course, wonder, what did we see now? Actually, what you see is that all these brokers do the same thing. They allow you to send messages from A to B with a broker in between. And actually, if you look at it, they almost do the same. And that's why, of course, the confusion gets there. which one do we need to take for what scenario? And that's kind of a difficult question, and that's the question I want to address during this session. So before we go into the differences of each service, let's just have a high-level look at what the services offer. The first one is Azure Service Bus. There we have two main concepts. The first concept is a queue where you have multiple senders of a message and only one receiver of the message. So that's perfect for doing load leveling. Load leveling means you can have a huge amount of messages on the sending side, but the receiver will process them at its own space. So here, the receiver receives each message at least once. You can take this concept a little bit further with publish-subscribe architecture, where you have actually a concept of topics, where the sender sends a message to a topic. And on a topic, you can have multiple receivers. Every receiver can create its own subscription. And actually, a subscription acts like a queue. So then the copy of the message, the sender sends a message to the topic, and in every 3 of the subscriptions, a copy of the message gets received. So each receiver, that could be different applications, can receive the messages when they want and at the speed they want. So this is perfect to do a publish-subscribe architecture, a Vanhoutte scenario. My advice is always to use topics, to be honest, because it might be that you have a one-on-one situation nowadays, but that maybe within a few months you have a new requirement to send that message also to another receiver. If you have already a topic created, you can easily plug in additional receivers if needed. The next one is Azure Event Hubs. And that's maybe the most complex one to explain. This is a partitioned broker. That means that the messages end up in different partitions. This is here an example of an event hub with 4 partitions, but you could go up to 32 partitions if you want to. Here, the messages remain for a specific amount of time in the event hub. By default, I think it's 7 days. You can increase that limit if you want to. But actually, your messages remain in the event hubs, even if you read the message already. And how do you read the messages? Well, you have multiple consumer groups that can read the message. One consumer group is actually one receiving application. And typically, you need to start 1 thread per partition. And so in this case, you would have 4 simultaneous threads that are reading the messages. And every thread is reading the messages from a partition. But of course, they need to keep track of where they are in the partition. So that's the concept of checkpointing. And that's kind of a keeping track, keeping a kind of a bookmark. Hey, I'm here in this partition. And so your threads can move along in every partition, and you can compare it a little bit like a tape. If something happens, some issues happened with the downstream processing, you can rewind the tape and you can start earlier again in the partition to read messages. So that's how it actually goes. This is optimized for stream processing and to have high throughput of messages with as low latency as possible. So this is really optimized for that. I compare it a little bit like reading a book, but every chapter in the book is a partition. So you read all your chapters at the same time, and you have a bookmark per chapter to still know where are you in the book. And that's a very fast way of reading your book. That's a little bit how I compare this to Azure Event Hubs. The next one is Azure Event Grid. We used to have Event Grid already available since 2018, and that's now called the Event Grid Basic, where you have 3 main concepts. The first one is system topics. That are Azure services who emit events when something happens. It could be Azure API Center when a new schema gets uploaded. It could be a key vault when a secret is about to expire. It could be an Azure storage that notifies you that a blob got uploaded on a specific blob container. So these are system topics, and they listen to these kind of events, and they will send a push notification, typically through HTTP, to one of your subscribers. You can use Event Grid Basic also just for your own applications, so as a custom topic. Then you need to adhere to the cloud event specifications. And there are also partner applications that integrate with Azure Event Grid. There are not that many. Auth0 is one of them. SAP is another one, and also Microsoft Entra ID and the Graph API are considered partner topics over here. But they made it a little bit more complex last year, because last year they also introduced Event Grid standards, also known as Event Grid namespaces. And on one hand, that's an MQTT broker, which can be used in IoT scenarios. There's full MQTT support over here, which is a kind of a competitor then with Azure IoT Hub. The main difference is that this is a full MQTT broker. You can use it to send, but also to receive messages through the MQTT protocol, which support wildcards, subscriptions, and these kind of things. While the existing IoT Hub support is only to allow devices to send using MQTT to the IoT Hub. You cannot receive messages over there, or you cannot do the publish subscribe through wildcard subscriptions. So if you need full MQTT support, Event Grid standard or Event Grid namespaces is the way to go. But next to the very particular MQTT support, there's also Event Grid namespaces, which allow you to do HTTP-based delivery of messages. You could do already push delivery in the basic Event Grid, but now you can also do pull delivery, where your receiving application takes the initiative to pull events from its subscription. So that's something that has been added recently, which makes it even more complex, and which makes actually this session even more needed.
So I got a quick question on that.
Yes.
With the pull now, early on with Event Grid, we did some stuff where we took and pushed the Event Grid into a service bus queue, and then pulled the messages off the queue to process them, so that, because we had a fairly complex process and we wanted to either complete or abandon the service bus message if something happened.
Yep. Mm-hmm.
Does that pull work similar to what that does then?
Actually, it does. I will share that in the comparison pretty soon. But indeed, it's kind of the same reliability mechanism that the Event Grid pull delivery has compared to the Event Grid. The Service Bus peak log pattern. Yeah. So that's the same mechanism there under the hood. Yeah.
Thank you.
Yeah, no worries. So let's compare now the services, because I think it's important to mainly see the differences, because each of them is just passing a message from A to B. So the first one is pull versus push delivery. So we are at the delivery side. The sender will also always push, of course, to the broker. The sender will take the initiative. Then the question is, will we pull as a receiver for the messages, or will we let the broker push the messages to the receiver? One advice here, pull is mostly the best option. So if you're in doubt, always go for pull. Why? Three main reasons. The first one is, if you pull, the receiver controls the processing time. For example, if there is a maintenance window somehow on your SAP system, on your ERP, on your legacy system, whatever, you can just stop processing for a while, even though the sender is sending messages. You stop just your receiver for a specific amount of time, and afterwards you can start receiving messages again. So you control when you process the message. As a receiver, you also control the processing speed. Imagine that there could be suddenly, it's the end of the month and 1,000 messages are arriving in your message broker. If the message broker pushes all these messages directly to you, you are overwhelmed, and you need to be able of processing these 1,000 messages at the same time. So when you choose for pull delivery, you control the processing speed yourself. You can choose how many threads, how many processes that you want at the same time, how many concurrency you want. Can you process 10 messages at the same time, or maybe your backend system is only capable of processing 2 messages at a time. And outbound connections, if you pull, it's always an outbound connection from a firewall perspective. They are more firewall friendly. Introducing inbound connections is actually introducing, again, a more risky connection into your firewall. So that's why, if you are in doubt, always go for a pull delivery. So if we compare, I think we need to compare 4 services. We have Service Bus Event Hubs. And with Event Grid, I make a distinction between the basic event grid that we used to have already for a long time, and event grid standard. So we see that Service Bus and Event Hubs are both a push-pull mechanism. So the sender pushes and the receiver pulls when the receiver wants it. Event Grid Basic, it's an HTTP push-push broker. So there the broker, the Event Grid, pushes the messages to you as a receiver. And in Event Grid Standard, you can choose. You can choose to use it like the Event Grid Basic, where the broker pushes it to you, or you can use the pull delivery, where you take the initiative as a receiver to receive the messages. So the next one, reliability. And here, Bill, we come to your question. First of all, you have the peak log pattern. A peak log pattern is a way to receive messages. And this pattern is actually implemented by two services. First of all, Azure Service Bus, if you turn on the peak log mode, and Event Grid Standard if you use the pull delivery. It's important to understand that the vocabulary and the namings that are being used are completely different. In Service Bus, you, for example, complete a message to acknowledge it. In Event Grid Standard, they call it acknowledge a message. So the terminology is different, but the concept and the pattern is exactly the same behind the scenes. So let's have a look at this pattern and how this makes sure that your messages are being received in a reliable manner. So we have a receiver on the right side, we have our queue or topic on the left side with a few messages in it. First of all, we will peek for a message. So the receiver peeks a message, and that message immediately becomes unavailable for other threads that are maybe also simultaneously receiving messages. We process the message, we put it in our database, we call an API, we do whatever we have to do, and then we acknowledge the message, and the message gets removed from the queue. Voila. Next, the next thread, and that can happen simultaneously, is also peeking for a message. Again, that message becomes unavailable for the other threads. You see a timer appearing. The message becomes unavailable by default for 60 seconds, but that time is configurable. That's the lock duration time. We process the message, but something goes wrong. Processing fails, so we are unable to acknowledge the message. Well, after a specific amount of time, you see that the message becomes available again on the queue, but there's a 1 over there in the message, and that 1 is indicating the delivery count. And the message has already been tried to deliver once, but it failed. So we receive again a message, and it might be the same message. It gets again locked for other threads to be received for a certain amount of time. We process the message, but it fails. And after that, the lock duration gets passed. After 60 seconds, the message becomes available again for another thread to be picked up. And so we continue, we pick the message again. You see that it's now been delivered already 2 times. Try to be delivered. We process the message, the processing fails. And because now the maximum delivery count has been reached, the message gets put on that letter queue, that letter storage, and all the other messages can be processed. So this is the peak log pattern applicable for both Event Grid pull delivery and Service Bus peak log pattern. So very important to understand this one. Of course, this was an animation. This is typically going around in a multi-threaded scenario. So maybe let's show a demo over here where we just use the peak log pattern in Service Bus. What I will do on the receiving side, I didn't write any error handling code. So I just process the message. And if I receive a message with number 13, I will throw an exception, an unhandled exception. So let's see what happens. I go to Service Bus. I say, okay, send messages with an exception, and message 13 will be an exception. You see actually here what's going on. All my green messages are being processed, so this is going fine. But you see message 13 has been delivered by default 10 times. So we try to process the message 13 10 times, but now we don't receive it anymore because by default, after 10 times, the message gets stuck on that letter queue. So maybe we can go to our Service Bus. Let's have a look. We have here Service Bus Explorer. We can go to that letter queue and say, okay, peek all the messages from the start. And if I go to the bottom here, we should see 1019. It's 1019 now. We have a dead letter message, and you see that it's indeed Service Bus message 13, because that's the one we always. So you see, This helps you with building reliable solutions, but of course, you need to make sure that you watch your dead letter queue. You need to monitor it. With with Azure Monitor, you can create alerts if messages arrive in your dead letter queue, or you can even subscribe on it with another process, because in the end, dead letter messages, dead letter queue is just another queue. So you can receive it with the normal SDK and stuff. So very important to understand this pattern. Next is the retry pattern, and this is used by Event Grid Basic and Event Grid Standard in the push delivery. So the retry pattern is used when the broker pushes the message to the receiver. So again, we have the broker with messages on the left side, the receiver on the right side. You push the message to the receiver processes it, it sends a synchronous acknowledgement back, and the message gets removed from the queue. We do again the same for the next message. The broker pushes the message, we process it, but processing fails. We return an exception, or maybe we return a timeout. We don't return anything and a timeout happens. But you see again, the message gets unavailable for the broker, but after a configurable amount of time, the message becomes available again and will be pushed to the receiver who tries to process it. Processing fails. And again, the broker will wait. It could be also with the exponential retry to resend the message, and after a while it becomes available again to be pushed. We process it, it fails again. We have reached the maximum delivery count. In reality, I think that's configurable and by default 10, but now animation would take too long. So we put the message on the dead letter storage, and we continue processing the other ones. So you see, this is the reliability with the retry pattern. So this is a little bit less reliable in my opinion, because as a receiver, if you are in trouble and maybe you are down, the broker continues to send messages and to resend them. So that's why these brokers typically implement an exponential back-off pattern. And Event Grid could go up to a retry pattern of 24 hours, just to make sure that eventually the message gets received. But if it doesn't, you at least have your dead letter storage where you can look for your messages. And then the last one is the replay pattern. This is applicable for event hubs because it has that typical stream processing. We have here on the left side our event hub, this time only with 2 partitions to make it a little bit easier to follow along. So we have a stream of messages in there. And so all the messages are in a chronological order over there. And we have a receiver. The first thing that he will do is get a checkpoint. And remember, for every partition, we have our bookmark or checkpoint. Where was the last message that we read? So for this checkpoint, it was message 8 was already read. For this partition, we were already at message 9. Maybe I want to show you in reality, if you use the Azure Event Hub's SDK, you will actually need to also provide a storage account connection string. And you might wonder, why the hell do I need a storage account? I want to read messages from Event Hubs. Well, the reason is that the SDK uses the storage account to store your checkpoints. Let's have a look for that. If I go here to my storage account, and this is a container I provided, the checkpoint container, you see the SDK created the name of my a folder here with the name of my Event Hub's namespace. Then we have the name of my Event Hub. We have the default consumer group that I'm using, and you can create other consumer groups if you want. And then they use it both for checkpoint and ownership. Ownership is if you have multiple processes belonging to the same consumer group, they will use that to do the coordination. Okay, you will poll for partition 1 and 2, and I take partition 2 or 3. And checkpointing is to store your checkpoints, your bookmarks, where are you at per partition. So you see, this Event Hubs has 4 partitions, so we have 4 blob storage files, but these files are empty. The size is 0, but you will see that in the metadata of these files, they are storing here the sequence number. So this is the sequence number inside the Event Hub. You will see in partition 0, we are at sequence 1703, but this one will be normally at another part, at another sequence. You see, this one is, they are not in sync, of course, because there might be more messages in partition 0 than in 1 and so on. This is how the service, the Event Hubs SDK keeps track of that checkpoint. You can configure whether it needs to persist that always on durable storage, or it can also persist it in memory. But of course, if you do it only in memory and you retry, you need to, you don't know the last checkpoint anymore. So it's advised to checkpoint on durable storage on regular intervals. Okay, let's get back to the animation. So we have the checkpoints, then we get the next batch of messages. And the batch size, you can also configure that, but typically we read multiple messages at the same time. So in this case, we have a batch size of 2 messages, and then we process that batch. We process the batch, we store it again in our database, we do some anomaly detection, whatever we have to do, and then we update our checkpoints. Now the first partition is already consumed until message number 10. The second partition we have consumed already up to message 11. Next thing, we get the last checkpoint again. Could be from blob storage, could be from memory, depending on your settings. We receive the next batch, hopla, like this, and we process the batch. The first receiver processed successfully and updates the checkpoints again, but processing fails on the number on the second receiver. So the thread that is consuming, let's say, the messages on the partition 1, on the first partition, it will just continue. Yeah? The other threads, yeah, the processing failed. So what do we need to do right now? It's good to know that if you use Azure Functions with the default event hubs binding, functions will just ignore your exceptions. So if you throw an unhandled exception, the message will get lost. We just continue processing the next messages in the stream, which means that you can have lost messages. So be aware of that. I see a lot of solutions running Azure Functions like this in production. You need to do some kind of error handling yourself. By default, this pattern is not 100% reliable. The only thing you can do is actually, if something fails, you can retry it. So you need to reprocess the batch. But of course, you cannot continuously reprocess the batch, otherwise you will get into trouble. So eventually, if after some retries it doesn't work, you need to dead letter the messages, and you need to put them aside and make sure that they get processed later on. But that's dead lettering mechanism, you need to build it yourself. You need to write an SDK for that. It's not built into the protocol and to the service. And that's a very important one to know. Azure Event Hubs is not reliable by default. You need to do some error handling yourself over there. So if we compare the services, we have Azure Service Bus using the peak log pattern with built-in dead letter queues. Fantastic. Event Hubs, you have the replay pattern, so you can go back in time, back and forward in time. But there's no dead letter queue. So if you need to put messages aside and do retries, you need to build it yourself. Event Grid Basic, it's the retry pattern by the broker, and it dead letters to blob storage. And with Event Grid Standards, it depends on the push or pull mechanism. The push mechanism acts actually like Event Grid Basic, retry with the broker and dead lettering to blob. If you do pull delivery for Event Grid Standards, you also use the same concept like the peak log pattern, and it dead letters to Azure Storage also over there. No matter what you do, no matter what service you use, no matter what pattern you use, you are dealing with at least once reliability. That means that some of the messages, if stuff goes wrong, will be received multiple times. So you need to make sure that the receivers of your messages, the processors, are idempotent. That means whether they receive the message once or 10 times, the result should be the same. I don't want, if I order new shoes, I don't want to receive 5 pairs of shoes because my message was retried five times. So you need to make sure that your receivers are idempotent. So that's very important to understand. Of course, I want to get 5 pairs of shoes if I only need to pay once. The next one I want to compare are the protocols. The protocols are being used. The Service Bus is built on top of the AMQP protocol. You have also support for JMS, Java Messaging Services, only available in the premium tier. And there's some support for HTTP. We don't have the full feature support, but basic send and receive of messages is supported within Service Bus. If you look at event hubs, also built on top of AMQP, you have full comparison and full with the Kafka protocol, which is quite popular nowadays. Depending on how much alignment you want with the Kafka protocol, you need to go up to higher tiers. For example, the compaction feature is only available in the higher event hubs tiers. There's also support for HTTPS, but even less. That's why I make it even more transparent over there than Service Bus. You can only use it to send messages to the event hub itself. Receiving messages in such a complex protocol is just not possible through HTTP. EventGrid Basic is a 100% HTTP-based broker. The EventGrid Standard also, but you can also turn it into an MQTT broker. So that's a little bit, I typically take that use case a little bit aside to the MQTT stuff. That's mostly for industrial situations or IoT situations. So the protocols, Service Bus, AMQP and JMS, Event Hubs, AMQP and Kafka mostly, and the event grids are mainly HTTP-based, except for the standard, they have MQTT support. Ordered delivery is also an important one. FIFO, first in, first out, the messages that have to be received in the right order. Azure Service Bus queues, they are, first in, first out by default, but typically your receivers are multi-threaded. From the moment they are multi-threaded, you cannot rely anymore on the order, because every thread is processing messages differently. So if you want multi-threaded receival of messages and still want to have some kind of FIFO, first in, first out, you need to enable sessions on your queue. This is something that you need to do at the creation time of your queue. So you cannot enable sessions afterwards. That's an important one. And also the SDK that you use at the receive side is a specific SDK for session-aware receivers. So that's very important. If you want to enable sessions, you need to do it upfront. And the idea is for sessions that the sender sends a message with a particular session ID, and all the messages within a specific session, so all messages with the same session ID, will be handled in FIFO by the receiving application. So I can show a little demo of that. Let's send, again, 100 messages to Service Bus, but with an offline receiver. So I will put my receiver offline. So I stop receiving messages here on the right side. 100 messages have been sent. Maybe I need to go even to my queue and have a look. But there should be 100 messages over here now. At least if my Service Bus Explorer wants to receive that. But you see already showing 0 of 100 messages, and here also 100. So yeah, there are 100 messages in the queue. Let's not wait for that. We will see them later on. When I press enter over here, you will see that the message receiver will start receiving messages very quickly. Voila. This is the default message receiver, and you see that messages are not being received in the right order. You have here 80, 82, 83, 81, and so on. So by default, if you go with a multi-threaded receiver, the order is not guaranteed. If we, however, send messages with order delivery, that means to a specific queue. So I created a dedicated queue for order delivery. We pause again on the right side. All these messages are being sent this time with the same partition session ID, not partition key, with the session ID. And if I now receive the messages, you will see that they are received all one by one. I could even do all the messages from lower than 50 to one session and higher than 50 to another session. But I think you get the point, right? So this is order delivery and Service Bus. Also, Event Hubs supports order delivery, and there the FIFO, the first in, first out, is guaranteed per partition. So all the messages that end up in the same partition will be respected in chronological order. Again, it's the responsibility of the sender to provide a partition key. And that partition key can be whatever that you do. But based on the hash of that partition key, event hubs will keep track of, that partition key ends up in partition 2, and that partition key ends up in partition 30, for example. So that's the responsibility that event hubs takes for you. So you could also provide a partition ID where you really say this code needs to go to partition 1, 2, 3, or 4. But I don't like it, to be honest. Only in very particular scenarios you might want to do that, because in the end, maybe you want to change the number of partitions and then you don't want to change your code on the sending side. So just use a partition key, and event hubs will take care of the mapping between a partition key and a partition, and event hubs will make sure that the partition, the load is as distributed as possible. All right, that's event hubs. We can also do a small demo on that. We send messages to event hubs like this with an offline receiver first. We send 100 messages. And after they are sent, we start reading the messages, receiving them. You see one messages are being received in a completely arbitrary order. You see 73, 151 and stuff. If we want the messages to be received in the right order, we need to send them. Need to go back here. It's event hubs number 2. We send with order delivery. Now I will send all the messages with the same partition key, so they will all end up in the same partition. And it also means that now the messages will be received in the right order. So that's important. Think about that if you have these kind of requirements. So order delivery is possible with Service Bus and Event Hubs. Event Grid does not support it. Next thing you often do with your message broker, I talked already about it, is a publish subscribe architecture. You send one message and multiple subscribers want to receive that same message. This is possible with every single broker in Azure. But sometimes you want to have some server-based filtering, some content-based routing. This type of message needs to go only to that subscriber. Or messages for Belgium need to go to ERP system 1, messages for France need to go to another ERP system. So which brokers support content-based routing, so server-side filtering? If you look at Service Bus, this is possible. Service Bus can do this based on the metadata, on the brokered message properties that you send. You have some kind of a SQL-alike language where you can provide filters, where you can, for example, say only message type and country. Belgium need to go to this subscription. Event Hubs does not support any server-side filtering. That means if you receive messages from a topic, you receive every single message that was sent to that event hub. So there's no filtering possible on the client side, on the server side. So you need to filter client side. But of course, definitely if it is sensitive data, you don't want the receiver to receive that data, you need to actually use multiple event hubs for that. Event Grid Basic and Event Grid Standard have the same way of filtering messages. You can do it both on the event type, on header data, and the data itself. Why is it possible also to do it on the data itself? Because these services enforce the cloud events specification, so they know how the schema, at least the basics of the schema, look like. So that's why you can do filtering with the predicates that are over there. So content-based routing is supported everywhere. Publish subscribe is supported everywhere. The content-based routing, which means server-side filtering, is not supported in event hubs. The next one is message sizes and throughput. It really depends on what tier you are using. If you look from a message size perspective, all the services support a 1 megabyte message size, except Service Bus. Service Bus has a 256 kilobytes limit. Except for the premium tier, there you can allow messages up to 100 megabytes, only using the AMQP protocol. Of course, sending messages of 100 megabytes, maybe you need to think about re-architecting your solution. Throughputs, and I only talk here about the ingress throughputs. You see that Event Grid Basic is a medium throughput, 5 megabytes per second. Event Hubs is the highest throughput you can achieve, an ingress of 2 gigabytes per second. But you can even go much higher if you get rid of the limits. So you can raise a support ticket to get even higher ingress if you need that for your scenario. So you can up to, I think, 100 gigabytes per second even. So it's really, really optimized for that enormous throughput. Networking, very important, definitely in an enterprise context. And the good news is all these services support private endpoints. So private endpoints make sure that your messaging service is not available anymore on public internet, but it gets its own private IP address within your own virtual network in the cloud. So every service supports it. Be aware, if you want it on Service Bus to be enabled, you need a premium tier. So that means quite expensive Service Bus for some companies. And then, of course, every broker has its own specific features. If you look at Service Bus, it has the feature of duplicate detection, where you can remove messages that were received twice. To be honest, I don't use that often, to be honest, because in the end, even if you have duplicate detection on a broker, you need to have idempotent receivers anyway on your receiving side. So I don't see much value in duplicate detection. Scheduled messages, that's a very nice one. So you can send the message to a topic or a queue. That message will only become available at the time that you provide. And so, for example, if you have an event and you need to send a notification 1 hour before that event, you can send a scheduled message, and that message will only be consumed the moment it becomes only available on the queue at that time. So that's very nice. You have also auto forwarding of messages. You can forward messages from one queue to another one, which is very nice if you want to build some integration between multiple queues. Or you can, for example, forward all the individual dead letter queues to a centralized dead letter queue. That's also possible. Without writing a single line of code, these messages will flow into the destination that you configure. And geo-replication is a very nice one. It's currently, it's been announced in summer 2024. Geo-replication means that your message gets persisted. If you send it to Service Bus, it can get persisted in 2 regions, in West Europe and North Europe, for example. And you have the option to do that in a synchronous fashion. That means you send the message gets persisted in the 2 regions, and then you get your acknowledgement back. If you choose that option, you have an RPO, a recovery point objective of 0. You will not lose a single message, but you have, of course, some kind of performance hit because the message needs to be persisted in 2 regions. If you want the performance hits to be lower, you can go for an asynchronous replication, but then, of course, you have a higher RPO. So you need to choose there a little bit between RPO and performance. If you look at event hubs, it has the concept of a schema registry, which is quite invested a lot. That's a registry to agree between the receiver and the sender how should the message look like, and it can be used to serialize and deserialize your messages. So this will be CNCF compatible, so that's an important one. You can also archive all your messages to blob. So if you have, that's the capture feature. With capture, you can automatically make sure that all the messages that end up in your event hub will eventually end up in your blob storage. And also Event Hubs has the same geo-replication feature like Service Bus. If you look at Event Grid Basic, just know we have the system events, the partner events. Be aware that the message needs to adhere to the cloud event specification. And so that's kind of a limitation in some cases. And you cannot do message inspection nowadays. So you cannot see what messages are currently being queued in the broker. And Event Grid Standards, be aware it's a full MQTT broker support if needed. Also, cloud event specification needs to be adhered to. And also there's no option to do message inspection, so really to look into the messages. So that's a kind of a drawback from an operational perspective. All right, we have seen the main differences between all the services. Let's now do some real life examples. First customer that I had, they required a by default reliable and secure message broker, but their budget was quite limited because they suffered a lot because of the high inflation. So if we look over here, first thing is by default reliable, the push-push mechanism of Event Grid Basic is not gonna work for them. Also, Event Hubs is not reliable by default. You need to do the replay or the dead lettering yourself a little bit. Service Bus, they wanted to be secure, but secure means networking, and networking with Service Bus means premium tier. That was too expensive. So in the end, for that customer, we ended up with an Event Grid standard using the pool delivery mode. Next scenario is processing. At the bank, we need to process financial transactions. If you talk about financial transactions, I think geo-replication is a very important one. You don't want anything to fail over there, so that's why I think the option should be Service Bus or Event Hubs. Because of the way Event Hubs works, it doesn't work on a kind of a transactional way on a per message basis. And the fact that you need to do your dead lettering yourself, Service Bus is a lot more optimized to process individual transactions. You have the automatic retries due to the peak log pattern, and if we monitor the dead letter queue well, everything will go fine. The next scenario is a customer of mine that had to handle an enormous amount of real-time GPS positions. And in the downstream processing, they did also some geofencing. So they knew when the person who did the installation arrived at the customer. They know when the left at the customer. And based on those time frames, they did actually the invoicing. So they knew the installation person was there for 3 hours at the customer, so we need to invoice 3 hours. So that's how it worked. A whole fantastic system based on GPS positions. So, but they also needed a broker, of course. First of all, Event Grid Basic was not an option because of the throughput. 5 megabytes per second was way too low for them. Or the delivery is very important. If you do geofencing, you need to process the GPS coordinates in the right order, because you're not in the geofence, not in the geofence, not in the geofence, and now you're in the geofence. You need to find the point where you enter the geofence. So that's why order delivery is very important. And then the way Service Bus works is not ideal for them. They also tried RabbitMQ in the past, but that didn't work for them because it's a message by message reliability that you have over there, but actually they need to process messages in big batches and retry the batch always if it doesn't work. So that's for them. Event Hubs was the perfect service to implement this use case. Next one is document processing. We need to process documents as fast as possible when they are uploaded on blob storage, but we should be aware about excessive peaks. So first of all, I think the system events of Event Grid Basic are pretty nice because we don't need to pull our storage container. We just get notified if something happens. But we get notified in a push-push way, which is not that good because in the end, if there are high peaks and maybe 10,000 of messages at the same time, how can we handle those? So in the end, be aware that Event Grid Basic, they can forward messages to your compute, to your serverless compute service like Azure Function or Logic Apps or whatever container technology that you're running. But they can also push to another messaging service, in this case, Service Bus or Event Hubs. The replay is again not optimal of Event Hubs, so that's why in this case I suggest actually a combination of Event Grid Basic system events and Service Bus queues. So this works like this. You have your storage account. From the moment a document gets uploaded, Event Grid Basic sends out a notification. It doesn't send a notification right away to your compute. That would be good if you don't expect excessive peaks. But if you really are expecting peaks, it's better to put it on the Service Bus queue. So now your queue can be read at the time that you want and at the speed that you want. Still use serverless compute, I get to have the maximum speed over there, but at least you control the concurrency of your receivers. And I think the last one here is we need to build an open, secure, cheap, and accessible integration platform to ensure reliable communication between local authorities of various sizes to exchange sensitive requests from citizens. Wow, that's a big one. Let's have a look over here. First of all, it needed to be cheap and secure. So private endpoints in the premium tier was too expensive for this customer. Again, the price of Service Bus premium tier, it just depends on the context. In some enterprises, this is peanuts. For some organizations, this is already quite high. It should also be open and accessible. That means the protocols that we communicate with should be simple to understand, and most of the developers should be aware of that. I don't think most developers know how the AMQP protocol works or know how the Kafka protocol works. We don't want them to use Event Hub's specific or Service Bus specific SDKs, because it needs to be an open platform and so built on open standards. That's why we go more for an HTTPS-based approach, because in the end, APIs is something that at least 90% of the developers can have. The push-push mechanism of EventGrid Basic is, again, not a good one over here. We are dealing with local authorities. Some have really limited budget to have their IT infrastructure running. And so pushing towards them will result often in failures and in the infrastructure not being available. So that's why a push-pull is better. So in this scenario, I would go for an EventGrid standard using the pool delivery completely over HTTP. So I hope these scenarios with the explanation help you a little bit understand how you can pick the right messaging service for your scenario. Of course, sometimes, even with the right messaging services, I see sometimes some challenges with messaging. The biggest challenges are it's difficult to agree on a contract. And typically, you sit together with the sending or the receiving party. You design maybe a JSON. Okay, we will send that message and so on. But the broker doesn't validate against that contract. So it could be that the standard of your message is sending invalid messages, and then you need to deal with it and so on. So it's quite a hassle to get that done. Also, self-service is not easy. And by what I mean, if you need, for example, on Azure Service Bus, if you want to create the subscriptions yourself and the topics and choose yourself, you need to get access to the management plane, but then you get access to the complete management plane. So you get also access to queues that don't belong to you. And so that self-service mechanism, which I truly like, is not really easy doable. And you don't also have fine-grained security. Often I would like to have fine-grained security, for example, on the message type. This receiver is not able to publish this kind of message or to receive this kind of message. So these are challenges that are not always easy to solve with normal messaging services. That's why I created an open source project, and you find it on GitHub through the QR code over here. And I called it API-based messaging, where I actually use Azure EventGrid Standard as the messaging service, but it could be also Service Bus, to be honest. And we wrap it with API management. So we wrap it with APIs around it. So the publishers publish their messages through API management, and eventually the messages end up in EventGrid standards. And then the receivers of the messages, they can subscribe and receive messages also through APIs. So how does it work? First of all, we have a complete open API specification, so a Swagger file that describes the whole API. So here you see per message type, we have here the message type project 1, V1, and invoice booked. We have 5 operations available, where the publish one is the one that is needed to send the message. That's already a good one. Second thing, there's security over here. So I have a config file that looks like this, where you configure your multiple systems. Here they have them an ID and a name. It's based on OAuth, so you can configure your own IDP if you want to. And every OAuth token has, of course, a subject. You can link multiple subjects to a single system. For example, if you use system-assigned managed identity, it might be that multiple logic apps identities belong to the same system. So in that case, we can just do it by providing an array of subjects. Then that system gets particular roles. So you see system 1 can publish and subscribe everything with the asterisk over here. Here, this one can subscribe on everything, but can only publish the customer onboarded V1 message. So in this way, you have really fine-grained security per system. You can determine, are they allowed to subscribe or publish this message type, yes or no. So everything is done based on the message type. There's also validation. So every message type comes with its own particular schema where you can configure your validations, the maximum length. You can introduce regulated expressions, required fields, and these kind of things. So API management will validate the syntax of the message. If you don't adhere to the schema, you will not get in. And eventually, your message will get published on a single topic in Event Grid. So let's do a demo on the publishing side. So this is here the repo that you will find. So with the whole explanation of how it works. So how you can set it up. There's an automated deployment for everything. So it works really nice. This is eventually, if you deploy this, you get a messaging API with a V1. And then you see here, there's a management tag where you can list your subscriptions. And then per message type, you have 5 operations available: the publish, but also the subscribe and unsubscribe, and the receive and acknowledge, which we will use later on. And then we have here the messaging API. This is actually in Event Grid that we are. So this is one single subscription with multiple, one topic, my apologies, with multiple subscriptions. You see now system 1 has 2 subscriptions for these 2 message types. So we are now system 1. Sorry, this is system 2, my apologies. I publish the message. You see here to the publish endpoint, but you see it's complaining that I don't have an authorization header. That's because I didn't send any authentication. So I will inherit the authentication from my parent, which is just using OAuth 2. If I now do this, it says, okay, the client does not have the required roles. So I don't have the required role to publish the invoice booked. So I don't have that role. So maybe I can try to send the customer onboarded instead. So let me send this message. You see, I get already a little bit further, but now I get a bad request and it's saying, okay, the property customer ID X has not been defined in the schema. And indeed, if you have a look over here, this is the metadata and this is the data of the schema. You see here customer X. This is a mistake. If I send it without the X, I'm in and the message gets sent. So you see how the security, both the security and the message validation really works well in this API-based messaging solution. Of course, we can now send messages. We also need to receive them. So to receive them, there's also an open API specification. First of all, you need to explicitly subscribe on a specific message type. And if you subscribe on it, you will get your own dedicated subscription on the main topic. And then you have APIs also to receive a message. Receiving a message is a long polling. So it will poll for 90 seconds. If there is no message after 90 seconds, you will get nothing back. If there's no message, but during those 90 seconds, a message arrives, you will get an immediate response back. And of course, using the peak log pattern, you need to acknowledge every message individually. So it's also optimized for logic apps. The long polling will make sure that you don't need to poll every second. There's also a propagation of the client's tracking ID, the Microsoft HTTP header. So if you have a logic app over here, your receiving logic app will share the same client tracking ID. So that's very good for end-to-end tracking. And we will make sure that when there is no message available on your topic subscription, that we will return an HTTP status 202, which will make sure that your logic app has the skipped trigger status. So let's first look at receiving the messages. So we have an endpoint to get our subscriptions. How many subscriptions do we have right now? You see, currently we are system 2. We don't have any subscriptions. If I look over here and do a refresh, we only see subscriptions of system 1, not of system 2. But now I can subscribe on the customer onboarded. Let me subscribe on this. This verifies also that the subscription has been created in the back. So it's an additional API call. If you now refresh, you see that customer onboarded subscription was created. Now I can publish a message. 1. Maybe I need to give it demo down under. Send a message. Now I can also receive a message. And once you have subscribed on something, you can receive it. Then you see here, I received a message with the demo down under. If I now look at the HTTP headers, you see here that there's a message token over here. And this message token can be used to acknowledge the message on the acknowledge API. You just need to provide this as a query string parameter, and the message gets removed from the queue. Let's do that receive again. I receive here the message. And you see this will now, because there's currently no message on the queue, it will remain open in the long polling for 90 seconds. But the moment I send the message right now, voila, it's also received over here. So that's how that long polling works. If in the end I want to unsubscribe, because now I can go to my subscriptions, and normally I should see that I have 1 subscription available here on the customer onboarded. I can unsubscribe also. If I'm not interested anymore in these messages, I can remove it. If I do a refresh, you will see that it's not here anymore. And also if I do my get subscriptions, you will see that you don't have anymore. So it's kind of a multi-tenant system also. Every system, according to your security settings, has its own set of queues, topics that it can configure. And then optimized for logic apps. I also want to show you that. On the left side, we have here a receiver where we just publish the invoice. So this is just using the publish operation. This is a message body, and we're using system assigned managed identity. So nothing fancy over here. The receiver is just using a trigger, an HTTP trigger, where we do the receive, a get on the receive, and also system assigned managed identity. And we check every second. But remember, there's a 90 seconds polling interval. So in the end, this does not cost us much. And you will see that it goes quite quickly if I run over here. And do a refresh on the right side, you see that the new message has arrived already. And so let's do another one. Run over here. Now refresh on the right side. You see a new message arrived. So that's really nice. And if you look at the trigger history over here, you will see a lot of skipped statuses during the night. So that's really nice. I'll disable this one because I don't want to use it anymore. Okay. Demo time. I was a little bit too fast. I did the demo already. So I hope you enjoyed this session. We looked at the various messaging services, did a big comparison, then also had a look on which service to use in what scenario. And then the last thing that I showed you was that API-based messaging solution, which is quite handy if you need to interact with a lot of parties. You need to agree on message contracts and these kind of things. I really like the role that API management can play in that. You then also have a central way to do your monitoring. So I really like that solution. So thanks a lot for joining this session or watching it afterwards, and see you later.
Thanks very much. We didn't have any questions during the session, but that was good. Thank you very much. And
You're welcome.
That's pretty much it for today. Thank you. Thanks everyone for either watching live or listening to the recording. And we will have another meeting in November. Thank you very much again.
Bye-bye.